Hey everyone, we're finally on to part 3 of this series of videos on installing a DRO onto my mill. Now in this part we're going to have a look at the Quill axis, which is the U axis, and I'm also going to show you a Quill stop that I designed and integrated into this. The whole setup is different. It's not like anyone else's. I didn't follow any instructions or any plans. It's all my own ideas. And I'm a complete novice here as well. I've never done it before, so it's brand new. I'm sure there'll be a few things in there of interest to you if you're doing the same thing on your mill. We're going to start by having a look at all the parts here on the table. I'm going to assemble it. We're going to put it on the mill, have a look at it there. And then past the end of the video, I'll put in all those machining and commentary clips, some sped up, some not. We'll see how it goes. I've got a ton of footage, and I'll just sift through it and see what's interesting. The whole point of this format is that if you just want to see what I've done, you can see it in this first section. If you want to see all the machining, you can see it in the second section. I'm not going to make you sit through all the machining and commentary just to see the end result. Let me know if you like that format or not. I'd be interested. So let's get on with it, and be sure to like the video. Really need those likes. Okay. Right, so here we are. These are all the bits we're going to assemble now. There's quite a few components here. We've got the Quill bracket. We've got the DRO head bracket with its mount. We've got the plate that goes on the side of the mill that holds everything. We've got the stop that we saw in part 2 in this series, so I've left that assembled. These things are, that's the chip guard mount, that's part of it. That also gets mounted to this. We've got the magnetic scale. We've got parts of the Quill stop that I've integrated into this. Up here is a track for the magnetic scale. A whole lot of screws and bits and pieces. So today we're going to start putting this all back together again. So I'll begin with this plate, which was that whole concept of putting an aluminium plate on the side of the mill here so that I didn't have to drill any holes into the mill. As I stated in my previous video, this is under warranty. I'm trying to not wreck it at this point. And so creating a plate and mounting it on the side seemed like a much better idea. And that's what I've done. I went to the trouble of coloring it like this, which was not easy because this isn't white and it's not off-white, it's somewhere in between. But I mixed a lot of paints together and got it like that. I also wanted to get this ripple finish that is on the case here. That was very difficult to do, but I did a pretty decent job of trying to replicate that. It's not too bad. Overall, I think this will mount and people won't normally spot that that's an add-on. Oh, of interest as well is the number of holes I've had to drill in this thing. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 holes. Several of which would have to have been drilled in the side here if I didn't have the plate. And note that I did make a mistake with one section and I had to re-drill them slightly offset. That would have been maddening if that had been in the side of the mill. So that's worked out very well. I'm happy with that. Let's get that mounted. There we go. Screws I'm replacing are these two here. Because I wanted to make use of those two original holes to hold this plate on, I needed to remount this thing here down lower. So that has new holes there, and it just mounts to the plate, not to the housing. So first off, we're going to poke these wires through the hole. I'll put one of these in. I countersunk everything so that I'd have a flat surface, and also to make everything located by the screws so I didn't have to shift it around or anything. Of course, I had to be very precise with the holes. So it's 6 holes in total that hold the plate on. 2 up there, 2 there, and 2 here. This is all in black now instead of the gray that it came with. Just because other parts of this are black, the plastic as well. One, two, three, four, 5, 6, 7, 8, 9, 10, 11, 12. 12 holes in that little piece. So we've got to start by putting these small screws through these top holes. This piece could have been 2 parts, but I didn't have a thick enough block to make it in 2 parts, so I had to make it in 3. That's the one. See, if I'd made this in 2 blocks, it would have been 1 L piece like that, the piece, and the other would have been this piece. But I didn't have a piece that thick. It was only that thick, about 22 millimeters above that. So next we're going to mount this on this plate. Again, everything's done precisely, so I've used countersunk holes everywhere because it's precise. Initially I thought I would have to allow for adjustment of all these parts against each other, like cut slots and use flat screws and so on, but in the end I decided to make it precise. And that worked out fine. There's one area where I can do some adjustment, and that's on the scale itself, and it's plenty. There's one more piece here. That goes into the hole underneath. There's a hole on top and a hole underneath, and the one underneath is threaded, and the hole on top, it starts at I think 5 millimeters, and then it gets slightly larger and slightly larger up to 6 or 6.5, I think 6.5 millimeters, until it hits M8 where the thread is. There's an M8 thread cut in there. So there we go, that's that plate. So this is the original part of the machine that was mounted in those holes, and now it's going to be mounted in those holes below it. So I've got to push all this through. There we go. So that hangs like that. Brown, gray, black, and blue, like so. And that just sits inside there. The wires just push in to the free space. We take this thing, put it over the top, and these are the original screws that were used in the holes above. All these holes have paint in them, of course. And that's the original chip guard, of course. And I can still use that if I want to. All right, so far we've got these 3 black pieces mounted to it. Let's do the clamp that goes on the quill. And it's 2 parts here, that and that, and a whole lot of screws. Now this part is a 4-inch piece of aluminium, turned down, offset like this. I've got the narrow bit at the front, like this. I've got a slot cut in there with a screw to tighten down. I've got a bunch of screw holes there. Those are these ones on the back. 3 of them are parallel, and then the last one comes in on an angle. Those are here, these holes. These 3 are parallel, and the last one is on an angle. They're all countersunk, and that one goes quite far in because I wanted it to go right heavy into here, get a lot of meat. I felt that this really needed to be extremely rigid, and it is. So let's put this together. It's probably the easiest for me to see. Shorter one in there, same short one in there, and then the longest will go into there quite far. And this little one, that's the set screw thingy, the squeezing one. I had to turn that down a little bit to make it fit. It's going to go in that hole there. like that. Now in the end I decided to polish these bits. I didn't do a great job, just a quick polish. It's good enough. There's a lot of strength in this, more than I'd hoped for actually. Really the only bit that matters is the front. There, because that's the bit that you'll see. Yeah, just give it a clean. I wonder if I should put anything on it. Let's use a little bit of silicone, shall we? Just so that it's not completely bone dry in there. I'm going to silicone those screws and inside the holes, just so it doesn't dry out. Okay, that's that piece. Bit odd, but it's the most efficient sort of shape I could make and fit in there. Put it up, get my little hammer, because I'm going to center it on the line. If you would have noticed that I put a flange in it so that it could be tapped up tight against this against the edge. And this is all in alignment with the plate, of course. There we go. That's how that mounts. From the front, all I can see is this edge here. I might put the DRO bracket at the back there, the head bracket. This may as yet be modified at this end, but for now it's just going to go in like that. In you go. There we go. And that's firm. Nice. Now, this bit here is much more straightforward. Pull that apart. Drop this in the top and in the hole, so in both holes. And that's the bottom. So that bracket is now mounted. What have we got left? The scale and the reed head. Now the funny thing about these scales, these stripes, and they go on the side of the track that the magnetic strip is on, but bizarrely you don't put the reed head on that section. You just put the reed head in the middle. Go figure. This is the little base piece down at the bottom here. Now that has these little screws in it, which I leave out because at this point it doesn't need any adjustment, but they can be used to adjust this if necessary. So we're going to mount that there using another screw that I had to turn down. I turned this down so it would fit precisely in there. Now I've got a nice thick block here for mounting against, a nice precision surface, and a very thick block with a long screw, so I can really tighten that up because it becomes part of the strength of the whole thing, in fact. So I'm just going to put that in the middle there now, not too tight, approximately there. And then we come up here, we take the scale, and we drop it through the top, like that. And now I will put the screws that go into the track underneath. Okay, so with the whole thing loose-ish, what I do want to tighten is this unit onto the track, and I'm going to push them both against the base. There's a bit of movement in these things. The screws are not countersunk. I'm just pushing both the track and the little base block against the flat surface. So I do that, and then I tighten up the screws that go into the ends of the track, like that. There we go. And I should point out that I milled all of the ends of all these tracks to be dead square, because they weren't. They were just cut on some cutter, and that's it. So I put them on the mill, squared them all up, so that it's repeatable. Everything's repeatable. So there we go. That's now sitting in there. It's not tightened yet, but there's just a tiny bit of movement in all directions. A little bit sideways, tiny bit back and forth. It's almost nothing. And that now moves up and down, like so. Now I can, at this point, just tighten it, and I will. It looks like it's just going to tighten down right in the middle there. There we go. That's how that works. Oh, I need to do the head too, the reed head. Let's do the reed head. This particular head is requiring to be very, very close to the track, a lot closer than spec. So I may be asking the seller to replace this one, but we'll see. There's just one spot on it where it loses, I don't know, connectivity. So here's the reed head. Now let me wipe this as well, because it's not with the silicone but with wax and grease remover. So I'm just making sure there's no silicone or anything on it. Now the way I've done this is the wire comes down from above. That sits like that. These are very long as I could make them, because they're going into the acetal. And I wanted to be able to tighten them up pretty well. Now to adjust the distance for this one, I'm using this feeler gauge. Just put it behind there, push down, and pull it out. I've greased up that track a little bit. I don't want to do that. It's all right, because I can still wide it out. Now I took the rubber wipers off this particular reed head because it just doesn't need them. If anything, they add more friction. So there we go, that's back in. The next part in this assembly is the quill stop. So how do we put this together? We put this on there. It's a little acetal washer I made for this. This has a little hole in it. It's basically the same design as my DRO bracket lock up there. And this knurled knob also has a raised bit there. So that goes through there, like so. The whole thing goes through this. Now this is the same bracket as comes with the actual unit here, but I've put a 9mm hole in it to fit this thing here. Get my little brass washery thingy, put that on there, put this through it, and then tighten it all up, like so. That's my quill stop right there. That's the whole thing, pretty much. Now what do we do with it? We put it up here, and this goes into the hole, one of those 12 holes that were in that acetal block, goes right there. Loosen it, take the 2 original screws it comes with, put them in there. So we put that there, little tweak on, doesn't need much. Done. That's the quill stop. So like that, it's off. If I want to lock it somewhere at a certain depth, I go to my depth, I go like that, and I'm done. Now I can get back to that depth anytime. Want to let it go? Plunk, just let it go. That's it. Integrated magnetic scale and quill stop. So I reckon that's pretty tidy. All that's done. I've got everything mounted now, nothing missing. Takes note of the aluminium plate that this is all mounted to, which masquerades as the side of the mill. My wrinkle finish, not too shabby. Alright, so there we go. That's part 3 in this series of videos about installing the DRO on my mini mill. So far we've got the mount here for the DRO unit itself. Not fully complete. It may get modified here at the end, but otherwise that's complete and working and really nice. We've got the this gadget here for the U-axis. I don't know why I could call it the U-axis, but there you go. And the magnetic scale and the read head on the side there, that's all great. Obviously this big plate here, which solved a lot of problems for me. Very happy with that. It looks like it's part of the mill. And I didn't know how I was going to integrate a quill stop in it, but I have. And there it is. I'm very happy with that. Especially happy with the simplicity of it. The whole concept, it's very compact and simple. Couldn't be better. Oh, plus I should point out, part of this, the reason I made it the same as that, is for the same idea that you don't want to break it. If someone or me pulls down on this and goes past the point that you've set, you're not going to break it. Nothing will break. It will just slip in the end. You know, the tighter you go, the tighter it is, but it will slip rather than break anything. So that's come out pretty well. The size of the knob is much bigger than that because I want to be able to get more torque on it. Something I haven't pointed out when I was putting it together, I think, there's a metal stop screw at the bottom of this plastic block. So the quill stop actually hits a piece of metal. It doesn't hit the plastic acetal. It knocks on an M8 steel grub screw down at the bottom there, just to give it a nice sharp point that it hits. I think if you stick around past the end of this video, I'll put in a whole lot of machining clips there. You can watch them if you like. I'll probably speed them up. Don't know yet. I'll wait till I get that far in the editing. So if you like any of this, if you like what you saw and you plan on liking the video, please do that now before the end, because it'll skip to the next one and we'll both miss out on the likes. So I'd really appreciate it if you can do that. Try and get some traffic happening. Next video, I will do the Z-axis, I think. I'm still planning on doing this all without drilling into the mill. I don't know if I'll be able to do that for all of them, but we'll see how we go. So there we go. Like, subscribe, comment, let me know how I'm doing, share the video, all that good stuff. I'll see you in the next one. All right, let's find a piece of material for this. No, not a seedling. Maybe, oh, here. Here. Oh, that'll do. There's going to be a lot of aluminium cut out of this piece of junk. And quite frankly, the teeth are not right for this. Not at all. I need something with far fewer teeth to be cutting through this. So we're going to put this in here, going with advice from one of the viewers, but also something I figured out myself in about 2 projects back. When we cut a piece off a rod to work with, and I've previously wondered how much should I give myself for stick out, because you're obviously wasting that bit that you're going to hold on to here. And eventually I figured out, and someone told me, thank you, that you should leave enough out that gives you maybe at least one more project. So with this project, I'm going to use about 20 mil, including parting and facing. And so if I make a mistake, I could potentially do it again and still have that much stuck in the chuck jaws. So that's how much I cut off there. The plan is, I haven't actually got a plan yet, but it's something like face it, turn it, just cut it down a little bit, and then I'm going to be cutting the center hole off center. So I'll probably have to get my 4-jaw chuck and try mounting it off center by 5 millimeters and see what happens, see if it wobbles too much. If it really does wobble too much to do any cuts, then I may have to do plan B, which is to put it in the mill and use a boring bar to cut the hole. If that fails, I could use a rotary table and an end mill to cut the hole. But that's my last choice because I think the finish in that case is the least good. All right, so that's 100 mil. My workpiece here is 102. So let's, I'll put this one, ooh, it's just gonna grab it. Only just. That is the maximum workpiece you can have. Gosh, there's not a lot. It's only holding on by that much because of the way these teeth work. So here we go. What a monster. This will be fun to play with. I'm just going to go in with my same old tool that I use every time. Did my last job with this. And now we'll do this one. Let's have a look. Oof. Oh, I'll get the speed down. Obviously the speed on the outer edge is very high with such a big piece. This is 400, 500 RPM. Very nice cut. It's very smoky. Getting up 900, 11, 12, top speed. Okay, wow, beautiful. So we'll do a little bit of a cut along here, just to clean it up. That's square, this will be square to that, then we can flip it over, and then just clean up the other side and do our work there. That's one, basically 1 and a bit hundredths. Beautiful. Now this surface, however I leave it, is going to be the top surface. So I need to get this looking nice. Really have to do it offset, I think. So we're going to do it offset. Now, should I, like I was just saying, drill it, bore it, and take it as far as, take as much out as possible in this state, and then return and do, and then offset it in the other jaws and do the remaining bit. I don't like a deep chamfer, just a nice, just one that takes the edge off. That feels good and still looks sharp. Beautiful. That's pretty fun. I like it. So here we go. Okay. And there we go. The whole thing is within 1.5 or 2 hundredths. That's fine. It's more than fine. So now we upset it completely and move it off by 5 or 6 mil. This one is going to be +6. This one, and we'll see if we can check this. Okay, so the deepest is 1 and the top is 7. Perfect. Done it. I've actually done it. Ooh, it's wobbling. The whole bench is wobbling. That's 700. It is wobbling. But I could cut, I think I can cut that. That's all looking super clean. 78.4. That's how big it is. 78.4. Oh well. God, it looks weird. It totally looks like it's going to be drilling off center. On. Hope these drill bits are straighter than the last ones. Squirt it. So that's pretty small, and certainly fits in there, no doubt about that. Take it out. Now we'll go out, back, and there's the cut. There's definitely that chatter that I could hear, that high-pitched whistling is visible all the way around there. There, 60.02 or 3. That's pretty good. In a little bit. I'm just cleaning up that edge. Cutting into the corner. Meaning I could use that edge like that. That's actually pretty good. This should be fairly straightforward, except for, let's see, I'm going to be cutting in how much? The thickest part of this, about there. Oh yeah, it's basically that. This is not very good, but let's do it. Here we go. It's gonna go bang, bang, bang all of a sudden. Here we go. I guess a cut like that is good. Now, I knew I was going to be doing a 4-inch part, but I didn't think it was going to be interrupted like this. Gosh, yeah. Okay, looks fine. Looks pretty good. I'm taking slightly deeper cuts there. It's a bit scary though. Are we doing a full cut yet? We're not. No, we aren't. We're still not there. Wow. Close. Couple mil off. I need to catch it with something, so I'm going to catch it with the tail stop and put that in there. Hurry up. Finally. Oh my god. Oh my God. It's hot, but not terribly so. So the flashing stayed on there. There you go. It was easy. So to face it, I'll put it in a normal chuck. So what I'm going to do is take this chuck off and leave that in there in case I need to make another one, in case I've messed this up. Ooh, ooh, that's hot still. Spin it. Next in. Okay. So we're going to lock that, bring that down, come out to the furthest extent, which is there, and we'll just start going in. That's ooh. Let's check the thickness of this thing. 1279, 1275, 1279, 12. Oh, that's bloody perfect. God. Yeah, I didn't. Okay. There. Let's get my new file. Yes, nice. Well, let me go in there with a little bit of. There we go. Let's take it off. Well, it's different from all the other Quill stock plates I've seen. It's going to go in there, you won't really see it at all. Somehow, somewhere, this scale is going to be mounted to it. So I've got to make a plate that attaches to this. Oh, oh God, it's such a tight fit. Come on, there. If it stuffs up, I don't know, I'll just do something. I'll fix it. Let's have a look. See, if I wanted to hide the head, I'd have to mill down to about there, and then the slot would be down there. on that weird angle. I think I'll have the head visible. I don't really mind that. Well, there we go. That's today's job done. Let's see how it fits. Surprising how much tighter it fits once I cut the slot in. So we go like that. So we just tighten it there. Well, it's tight. There's no doubt about that. I'm basically going to start chopping a radius into it with something. Okay, here we are back again today to continue with this quill bracket project. Now yesterday I completed the screw here, that locking screw, and the slot in that, and did a lot of thinking and measuring and trying to figure out what I was going to do for the, whatever the extender bracket is going to be off this. And I've decided at least then it's going to involve this bar, so I squared it up, and I've also determined that I'm going to mount the magnetic scale like that, and this gives me 2 pieces like that. So I'm going to cut this in half, do that on the bandsaw, and then we'll come up to the mill here and just clean them up. Right, how are we going to cut this? Make sure that's off. Power on. Get some CRC. I might need my vice jaw saver. Vice jaw saver has the best tool in the world. Alright, you're going to go there, buddy. And then this bit's going to come over here. And y'all can see how that's going to fail, can't you? $24.83, 25, 25, 25, 25. 2501, that'll do. There. Okay, that's the idea. Are we good to go? I mean, look at that surface. That's the bandsaw surface right there. Obviously it's got lines, but you know, that's got circles on it. Seems just as good. That'll be mounted like that somehow. Now, how do we fasten this to this? So we're just going to be left with an L-shaped block here. I could do what I was saying, carve out this curve halfway into this. And over here, I'd shave it off. I'd just mill out a flat, also halfway down, put them together, screw. But I still could just, if I'm going to make that curve, well, why don't I just go all the way through and then fasten it with screws like that. And then the scale sits like that and can be adjusted. That's nice. Very simple so far. Simple as I like it to be. So that allows that much space. Take that out, whatever that is. And so now all I need to do really is find this marker, pull this up tight, and then score that. Ta-da, there we go. All right, I did a session without the camera because I just didn't know what I was doing and how I was going to do it. I've pulled out my rotary table, which I've not yet set up and worked with. It's really stiff and, yeah, not that great at this point. But I got it working, got it centered. I'm going to cut a radius out of this piece all the way down. So I've got a sacrificial piece of metal right there. And then I've just got another block there so I can lift the whole thing up. Got an 8 mil in there. I actually used a wiggler with a sharp pointer to make sure I was going to follow the line there with it. And so I did that, and then I've moved it 4 millimeter out. And I should be able to now go around. There's just enough room here to do this. And if it works, I should be able to go around and go all the way through. The trouble is, once it hits all the way through, it's going to be a problem because this clamp is holding on to the bit that's going to come away. This clamp is holding on to the end of the bit that's going to stay. And then I've just got a screw over there with a nut on it, just grabbing the edge of that, but that's probably not going to do anything. And that's all I can do. I couldn't get any other clamps in there, nothing. So I'm going to give it a shot. I'm going to do a very light, very shallow cut and go all the way around, make sure it works and I've got clearance and everything. This rotator is hard to turn. I can't get it any better at this point. I'll have to work on that later. So we're just going to go down a little bit and around, see what happens. We'll start going in till we get a touch. Ah, what a fail. What a fail. These are very short mills. I bought these nice cobalt ones that work very well, but they're short. It's not going to work. I'm going to have to use the 4 flute. So this should be fine to just swap this over. But that first cut was good. Let me just check this. I do believe we did. Gosh, there we go. Well done now. So I've done this cutout there and everything held together well. And I believe I've taken it low enough where I've just gone into this piece underneath here. I should be able to just pop it off. Oh, you know, there's a bit of a step in this one here. As if it shifted. I don't care about that so long as the back didn't shift, and the back looks fine. 17. There we go. And there's the lift I was just along there. I don't think I can fit this in there. I can. Oh, what a beautiful fit. Oh, what a beautiful fit that is. Nice. There we go. And I didn't think it would be as nice a cut as you can get on your lathe, and I was right about that. It's going to go there. It's going to go something like that. Very good. Very simple. There we go. Weird looking. But in my head, that was it. That was the sort of minimal thing. Get maximum meat on this side of the clamp, minimum on the front, as small as possible, and then just whatever the minimum is that comes out here, and that is just that, just enough to take the magnetic scale, nothing else. Yeah, good. Very happy with that. Right, here we go. Yet another day. This is, what is this? First day of 2024. And I'm playing in my garage. What could be better than that? Yesterday, I finished this piece here. So I put that away, and when I made this cut using a rotary table, which I've purchased but I haven't yet set up, and I clearly need to do some work on it to get it running smoothly and precise and so on. So I'm going to do that, and there'll be a separate video on that when I get around to it. However, I was able to get the job done, managed to cut that out with an 8mm end mill, using this as what they call a sacrificial piece, meaning it's going to get cut into, and that worked really well. Real pleased with that. Things that didn't go so well were clamping onto the table, on the rotary table. That was hard. I can see why people complain about the Vertex 6-inch. They complain about it only having 3 slots, and the one I got has 4 slots, and even that's not really enough. But yeah, you need slots all over the thing in order to get your clamps on it. So I'm going to have to look at that in the long run and make some clamps. Maybe I'll design something interesting for that. But the cut went well. I could only hold it there and here on this piece. And in the end, this one here moved a little bit with each cut. So there's sort of a pattern you can see there going down. There's even a bit of a jump by quite a bit, 1/3 of a mil maybe on that side. But on the other side there isn't. And there's no corresponding jump on this side. This side is all the same, so obviously this side was moving. So we've got that, but that's fine. That's not the side I want. I want this side. And that side has worked out very nicely. I've got basically the exact radius I had here on this piece, so I'm pretty damn happy with that. There's a little bit of an unevenness here, so what I'm going to try and do now is use this piece and some emery to smooth this face out like that somehow. Obviously this nylon kitchen thing keeps it all slippy. And over here, yes, there was a little bit of a step there that I could feel. The real question is, how am I now going to mount this? Any screws I put through are going to hold it tightly against that, so it's not going to go that way. But there is potential for movement like this. So I haven't fully decided how I'm going to do it, but obviously this is going to be clamped in there somehow, and then I'm going to somehow clamp this to there somehow. And then I'm going to start drilling somehow. I could find myself not able to clamp it, is what I'm saying. Is that on? That's on. How's that for alignment? God, that is too heavy. But let's tighten it up and see if it improves. It probably won't. Let's bring in one of these after all, just to keep it in alignment over here. Am I done drilling? I think I am, yes. What a... Oh, brilliant. Very good. Don't know if I'll be Loctiting these. I've thought about it a couple of times. So that's 3 of the 4 holes, and that looks like it's going to screw together very well. That one can be the longer one. That's strong. Obviously, that's strong. It's certainly out of the way. This bit. That's the thing it's closest to, is that. But because the scale is going to be mounted on that panel and it won't stick down, doesn't really matter. Nothing can touch it. This is going to go on it. It's going to mount right there. Finally, some progress. It's basically in the perfect position. Looks like the tape is just on one side. There. And there's swarf in there. Okay, that's all free to go. That goes to there. But because it's got this little knurl there, it doesn't go all the way. So let's go to the lathe, turn that outside edge off, and take a little bit off it. That's a good close fit. Well, this is good because there's plenty of thread into the aluminium. And that is not going anywhere. There we go. So the way this works, I'll just bring this down and lock it. And at the moment, I've just got a tiny little mark on here that I line up with the rear of this little slot. And that gets me into the right spot. So I'm going to do that. About there. There. Clamp it tight. And now this should be parallel with that face right there. And it misses it by 2 millimeters, 2.5 millimeters or so, just behind that. And that allows the scale to be mounted upwards more and out of the way of my tool arbor lock system here. And just generally keeps things out of the way, which is nice. Now the scale, of course, I modified slightly to take a larger screw. Got an M5 in there, and I've made it fit very nice and tight in there. But of course I've got these little grub screws which I could use if necessary to make adjustments, but I don't anticipate having to do that here because this is all square and in alignment. There's nothing that's going to be out of alignment. The design I have in mind is going to be sort of self-aligning. Good. I've got heaps of material here for the screw to go into. It goes all the way to the back, which is nice and really tight. So there we go. Finally, the magnetic scale in action there. Fantastic. I've got about a centimeter of clearance here, which is nice. I'm not covering up any screws or anything. I've got plenty of room here to mount whatever I'm going to do to affix this and attach the reed head. The reed head can go anywhere from here, that would be the bottom of its position. It could go all the way up to there. Could be up there. So that's a big range. Okay, that's perfect. And so is that. Excellent. So if I need to pull this off, I could just undo those two screws and take the track off here and leave this attached. Yeah. So what we're going to do is come up with some way. And I think I'd like to make this track thing out of acetal. And I may even make the whole thing out of acetal, because I think for this purpose, acetal is dimensionally stable enough, because I'll have a block like that. And if I mounted the reed head to it, it'd stay there. Then I have to discuss this on the board. So I've cut off a piece of acetal here, black I decided on. Otherwise I've got a fly cutter which I need to cut a new tip for. Okay, so we're going to use the drawbar lock to undo this. I'm going to put this one in, which has got 5 nice teeth on it. Do need some kind of speed up thing for this. People use like drills with a little fork on the end. Not sure, I'll come up with something. How fast is this? It's not too bad. Let me see if I can do this already. I need a 13. That means pulling it out of, oh, there's a 1/2 inch. That fits. Bingo. Perfect. Ta-da! Now this is operating on the nut, which is used to address just the end play. As far as I'm aware it is, the end float. But it's a lock nut that's on there. We'll give it a try for a bit, see what happens. I need one up there as well. Oh. Oh. Gosh. I'm done. I'm finished. I'm just going to use that, but what I'll do is I'll do something with the nuts to make sure they're locked on. I'm not quite sure. Maybe use two nuts and lock them against each other or something. But there we go. Oh, can I make it go up? Is it strong enough? It's heavier, but it's strong enough. Wow. How great is that? Very great, I say. It's not adjustable speed-wise. Otherwise, I could make it actually do a power feed. But certainly the idea of just a handheld thing that you just put over here and go bzzzt seems good to me, because you can make it's portable. You can put it here. You see, I can go that way. I got power feed in both directions. So I'm thinking when I make a power feed, it might end up being a portable thing that just is part of your hand rather than part of the machine. And whichever axis you want to power feed, you just go there, click on, and do it. That's what I'm thinking. So let's say that's behind there. And then it's got a block attached like that that comes over the edge. And the reed head sits up against it. So here we go, 50 by 75. Now this, yes, it's going to get cleaned up on these two faces. So scale sits on that one. Then this one is going to go over the top of this scale and hold the reed head over the middle of the track. So let's see, the reed head is just about 13. This is 20, just about 29. And the middle of the 13, let's just grab a drill bit just for fun. Who needs CAD when you got drill bits? So 7.5. That's fine, isn't it? So that sits like that, and then the last bit is, that sits in there, goes back and forth, very nice. The last bit is a piece up here. It doesn't strictly need it. It could just come up to there, right? It doesn't have to go up and over. It definitely doesn't have to go up and over. Just come up to there. And that's what when I had just two pieces, that's what I was going to do, but I didn't have enough material in this to do that, to come up. Because by the time I'd cleaned it up, there was only 1 millimeter left or so. But it could basically go like that, and it stays in with just the barest minimum here. You know, I don't want a great big thing like that, but a small thing like that, a small piece. So I need to do the hole, and it's just going to be a hole all the way through. Okay, the whole thing sits together approximately like that. Then I'm going to have this pin mounted on the rear, going down a hole. Want to keep it cool. That's my quill stop. So the next is to tap using this. I got to be careful here because it's plastic. Let's just go in. So let's just say that that's given me 17 mil of thread, hopefully. Let's have a look at our screws, see what's going to go in there. Probably M4, probably something like that. It can probably cut its own thread for quite a bit of that distance. So let's try 7. What else? Next is to do the tapping, and so for that I really need to just take this top bit out, keep the same depth, and just go in. So let's undo the vise. No, let's undo the vise jaw saver with the wrench. We can take that off, and that's still locked in. How great is that? Very great, I say. Over we go. I wish I had a DRO so I could remember these spots. It's easier second time around, isn't it? Thank you, Vice Jaw Saver. You are the best tool ever. Seriously. All right, we are many days into this project of putting the DRO on my mill. It's moving along very slowly, but I'm getting there, and everything is working out very well. I'm extremely happy with the results. Now, a point to make is that here are these lines right there, and they appear to be on the side that the magnetic strip is on. I don't know why they've mounted that on the side, but there you go, that's how it is. And here on the side of the head are other lines, so they need to be on the same side. Right, now in addition, this is going to be around it. That's going to go through there for the first time. Now there's just tiny bit of movement in both directions, twisty, sort of side to side, and forward back. I'm going to try and mount it precisely where it needs to go, as opposed to mount it with flexibility. A bit like I did the sides here, I used countersink screws because I just put it together precisely, I machined it precisely. I don't need any adjustment. The adjustment I'm allowing is this piece here, that screw, and these little grub screws. That's the adjustment. It's lifting it slightly up high, so it's tilted back a bit, meaning the track, the head at the end of the track is not precisely machined the same, which is not surprising as they're just chopped off. You know, I'm going to look at that very carefully. I could always mill them square. Yeah, I can see it's got a sort of a bump area in it. Now that piece, these things here, They obviously look square. They're a cast piece. They look very, very square. I'm not going to machine those at least. All right, so that's our first job of the day, and I think we'll just do it off the side of the mill. Right, all that matters here is accuracy that way, it's trammed in, and we're going to go from the back forwards, I think. Let's use my new power feed, which I'm extremely happy with, but I'll look for a good quality equivalent, maybe with some speeds or variable, but ta-da! Obviously I'm taking just the minimal amount off this, just enough to flatten it. I wonder if I should square all the scales up. I probably should while I've got this set up. Why the hell not? Oh, perfect. See, that wasn't doing that before. It was getting tighter up here. So that's now all square, which matches with my machining, of course. So there's a tip. Square off the ends of all your scales. I'm going to do that. Nice. That is so nice. That's bloody perfect now. That's very square. See, what I'm going to do is once I've set this up, if I need to remove it, I'm only ever just going to pull the extrusion off that block. I'll leave that block in place. And that feels absolutely perfect. Couldn't be better. Now those little screws, I'm just going to tweak them on so that they don't come out there. So how are we going to mount it? This can either sit behind it and you don't see it. Be nice to get to the two adjustments there, but once it's set up, it's not going anywhere. Let's just sort this out. If it was there, so the pin sits behind there in the hole in the back of the block. This goes up and down. Oh, the pin just sits there. Nothing happens to it. If it was tightened, then right now it would go up. And as it goes up, there's a point at which it would come out. But I'm allowing for 8 to 10 millimeters, and in fact it just gave me about 8 before it came out. Point is, I don't think the only way you could make the pin pop out of the hole is if you manually pulled it out and then tightened it. I'm going to aim for the top edge of that. I think more important than anything is I just get this thing aligned square with that. So I'm gonna hold the thing against, I'm gonna squeeze it together like that and try and not put any movement on it, and then I'm just gonna draw. So those could be something like that. All right, we're back again. Now, in yesterday's session, the memory card filled up on my camera, and I don't know how much I lost. No idea. So what I've done today, well, what I did yesterday, was finish this. Drilled all these holes, got all this lined up, tapped them, and took this off. And now I got to clean up this these burrs here and pull all this to pieces. Just assuming all these holes lined up properly. There's always a chance they didn't. Well, that's completely wrong. Oh my God, I did it wrong. I did everything right, except when I put this on, taped it on for drilling, I had it put it the wrong way around. I must have put it that way around. Oh my God. Hang on, but that's in the right position. What's going on? So how can I fix this? I need to drill all these holes. I need to glue that back on there, shift it, and then mark my holes again. How can I clamp that to the vise? Stop forwards. Perfect, of course. This is how I had it in my head when I was looking at this, but it just seemed like so much work. And it's taken a while, but it's good. These are just little round head ones, quite long. They fit in nicely. Give me about a centimeter on the other side. Now, as I said, this one doesn't need the wipers, but I can always put them on. It's easy enough. So that's ready to go. All right, Mr. DRO. I think that's memory recall. Now, do you think the U is working? Here we go. There it goes. 52, 46. Why is it running out there? Turns red. I can make it work. It's 0.15. But that now does it. So we'll do that. So let's say we lock the head there. We go plonk, zero that. I'm happy having values spare there because the hundredths is what I'm working on. Well, let's put it there. Take it away. 25.41. Well, that's bang on, really. All right. It's good to have those LEDs. You wouldn't be able to tell otherwise. Not really. You'd be wondering where the fault was. Now, I guess I'll have to think about this little block. How's a little block going to work? What's it going to do? Similar to my other little gadget there, I'm going to need a block, which could be the block that comes with it. Could be this. I could use this as the thing that holds it. I don't have to remachine that. Let's see if we can design this. Okay, so this was a failure. This didn't work out in the end. I've given up on it. I made too many mistakes, and in the end I drilled that hole in the wrong place. I just couldn't line anything up right. And it was just that little bit too complicated. I didn't really want it to be like that. So I've reverted back to my original design, which was to use this block, which comes on the scale, and basically do the same thing but with this. And so I used the faulty one of these and drilled a new hole in. This is from my DRO head bracket. So I shortened that, drilled a fresh hole, so that's going to be ready to go. I need to make one of these collars. The collar will simply sit up against the back there. This will go through there, and then somehow I'm going to have a screw, a knurled wheel on the other side that will pull it tight. That's it. Okay, how far are we going in here? I think about... Right, so that's the block. This will sit against the block. That will be held in place against it. And this here will pull it in. So far, all very simple, right? So I just need a hole in this and a knob on the other side. That's where we're at so far. The wheel can easily be a centimeter thick. So basically like that, and how the diameter can be anything I want. Haven't got any short bits in there. So what are we going to use? I've got so I missed all that recording. I've got the rod in here. I've center drilled the end, put the live center in, and I'm cutting myself just a little flange for the knob. But I do plan on having a washer as well. But So, knurling. Nice. Very nice. Let's go with that. Couple of lines like that. So now give it a clean with the paper here. So all we have to do is put these bits in here, these screws, the original screws back in the original part. So the only mod I had to make was to make that hole bigger. There. Done, basically. To put on the rear, which may be a bit fiddly to get there. All right, so let's say I want to set some sort of depth here. How would one do this? Let's say you come down to a certain spot and you go, okay, that's my starting place, 0. And then you want to go 20 mil down from that. So you might put this little thingy on here, undo that, and start going down. 10, 19, 20. And that's where we want it to stop when we crank up and down. So now I come over here. I know that that pin is just hanging there like that. I'll lock it. I can get a good grip on that too. It's great. And there's really nothing that can break. I could crank that up as tight as I can, and there's nothing that would break. So now I can undo that thing, and there it is, 20.0. Nice. So today I'm going to disassemble all of this because it's ready for finishing touches, and that means spraying this plate and this arm. And that's all polishing up the thing underneath. I'll get the magic Quill clamp remover here, put it in, go like that, spread it wide, there we go, and it all comes off. So I think that we'll try polishing that up, see if we can make it look tidy. Probably not visible. And it goes through, it's not opaque, but I'll be spraying it after it dries. So now, I think the last thing in the project is a nylon washer, very thin one. It's going to be the same as that little raised section there. I'm thinking maybe I can do it from the rear of this. That hole hasn't been drilled all the way through, so it should be fine. The idea is to help this surface, keep that tidy, and let this have a bit of slip. It's a bit like torquing up a greased bolt, or one with anti-seize on it. You end up making it tighter, and that's what I want, is to be able to just make it a little bit tighter. It certainly is tight. That's it. Good stuff. I think that's all the parts.